to discuss about the uh, RNN and some basics, some of the applications of the RNN and what is the structure of the RNN. Then we are going to see the one case study. Later, we are going to discuss about uh, different variant of RNN that is called as a LSTM, and then some of the one case study about the LSTM. So this is the today's agenda. First of all, we discussed about RNN, and then we're going to discuss about the LSTM. They are the two concepts we're going to discuss today. Okay. So now, um, in the previous classes up to now, we discussed about the um, ANN, and what we call one more thing is the CNN, convolutional neural networks. And now today we're going to discuss about RNN and LSTM. Okay, now. So for all these things, the basic thing is ANN only. Okay, now artificial neural networks only. The variants of different networks are called as a CNN, RNN, LSTM. So for the ANN, we are going to give the data in any form of the data. For example, you may give the data in the text format, okay, or you can give the data in the form of numerical values. Okay, any value you can give the data in the form of for the ANN, but there is some drawback in the ANN. What the drawback already we discussed in the previous class, like if more number of hidden layers are there, more number of inputs are there. Suppose if any loss is there at that time, it takes lot of time. If more number of parameters are there, it takes lot of time to evaluate all the things with the help of back propagation. So in order to overcome that one, suppose if the input in the form of image, okay, at that time we are going to reduce the number of parameters with the help of our CNN model. Now we are going to see the RNN and LSTM. All these things are based on the text messages only, text messages. Okay, now. So if that is simply it is in the form of a time series data. Okay, based on time series data or text messages, we are going to work out on the recurrent neural network and the long short-term memory networks. Okay, they are the two advanced concepts of the ANN. Okay, now. So now we are going to see the some of the applications of the RNN or LSTM like that. So here we are giving the input as one image. Okay, so here the image is contains a dog is there. Okay, this is a dog. The dog flies in the air. Okay, and also there is some object is there. Object is a simply it is called as a ball. Okay, now we are going to generate the caption for the that corresponding image. Okay, this is done with the help of recurrent neural networks. Okay, now. So simply we are going to generate the like caption like a dog catching a ball in the mid-air. So like that we are going to generate with the help of our RNN or LSTM. Okay, now. Then we are going to there are different types of translators are there, like Google translators are there. Suppose you are typing the one text message like in English. Okay, you are typing some message in a English like language. Are you okay? Automatically the Google is going to convert that content in multiple languages at the same time. It may be in the form of text message, or sorry, in the form of a voice or text or whatever, maybe in different languages like Telugu, okay, or Hindi or Spanish, like that. In multiple languages we are going to convert the same message in multiple languages. That is simply is called as a machine translation. That is one of the major example of the or recurrent neural networks or what it may be LSTM. Okay, now. So they are the two major examples of the applications of the RNN. Now we are going to see the in details of the our RNN. Okay, now. In the previous class, we discussed about the ANN. What the ANN? ANN is simply nothing but one neuron. For this neuron, we are going to provide the some inputs like X1 and X2, and some weights are there. W1 and W2 are there, and we are going to perform the some operation sigma, and then perform the activation function, and then we are going to get the output. Okay, now. Suppose if you are having the multiple inputs are there, okay, multiple inputs are there like here, okay, X1 and X2, like that we are having the Xn inputs are there. So these are all are called as in the form of, at the same time we are giving the input for the our neural our hidden layers. Okay, in the hidden layer, okay, you are having the n number of hidden layers are there. For example, here 3 neurons are there, 4 neurons are there. For the 4 neurons, we are giving the all these n number of inputs to the our hidden layer, and each hidden layer perform the sigma operation, then activation function. Okay, based on that, we are going to predict the output. Okay, now based on that, we are going to predict the corresponding output. It is a so here the input is here is a federal giants all time grades. So there the x1 is nothing but a federal giants is on x1, so this is x1, x2 and x3 and x4 and x5. Here the 5 inputs are there. Based on these 5 inputs, we are going to generate the corresponding message belonging to which type of what type of corresponding class label, like it is a sports news or political news, like that. Okay, so this is possible with the help of our artificial neural networks. But what happened here, the input in the form of a normally we are going to based on the federal only you are going to generate the output here. Because why? Because it is a federal becomes belongs to sports person. Okay, now sports person. But what happened, normally you have to read all the data sequentially, then at the last time, after completion of the entire sentence only, we have to generate the output. Okay, so in this model, if you are using the ANN model here, we are not sometimes we may get different output. Okay, that is the drawback of the our artificial neural networks. To not avoid that one, we are going to use the concept called as a recurrent neural networks. Okay, now. So now here, so this is the at the time. These are the at the time stamps. Okay, there are we are having the 5 keywords are there. Federer, giants, all time grades. There the different words are there. These are called as a x time t, and this is the x time t minus 1, x time minus t minus 2, x time 3 minus 3, x time t minus 4. That means at the present time, okay, at the present time, what the input? This input depends on the previous input also. Okay, previous node input. So this all depends on the giants. So xt minus 3 depends on the xt minus 4. That means the present node input to present node input or present node output depends on the previous node inputs also. Okay, now. So at that time, we are reading the first node input and perform the output here, and then we are going to apply whatever the output is there, that is carry forward to next layer as a input. Okay, and read the present node input and perform the based on the previous node input, and present node input, we are going to generate the new output. That output is transferred to next layer as input, and based on the present node input and previous node outputs, both are given to our node. Okay, and then like that we are going to generate the output here at the time t. At the time t, we are reading the input from the previous node outputs and as well as the present node input, and then based on that we are going to generate the output. Okay, simply this is a time series data. Okay, the final output depends on the final data. So here this is a node is there, that node generates the okay, and so here this is the present node input, that is x. For example here x1. Okay, it reads the previous node input, that is h1. Okay, and we are going to perform some operation here. We are going to get the output, that is okay, that is we are getting output as a h okay, h plus 1. So this is for example h0 and this is h1, and now for the next input, okay, that is x2. We are going to get the read the output, okay, from the x2 and the previous node input, and we are going to generate the next output. Like that we are going to get the output. This is the way we are going to generate the things. Simply this is called as a recurrent neural networks. So here we are going to get the two things are there. One is O1 means nothing but output at present node input. After reading the present node input and the previous node output, we are going to generate the two outputs. One is hidden layer information, that is carry forward to the next layer as input, and the output at the present node. Okay, like that we are going to get the output. So like that we are going to get the t minus 1. Okay, this is x t, and we are going to get the ht, and we are going to get the ot. So like that, we are going to generate the outputs here. Simply, this is called as a recurrent neural networks. This can be represented in a only single network, that is like here. This is a one neuron is there. Okay, for this neuron, we are giving the input as a xt. Okay, xt, and based on that, we are going to generate the output. Okay, based on that is a ht. Okay, and then that output is carry forward to once again to the next layer as input, and also okay, we are going to get the output as a OT. Okay, simply this is simple representation of the network is called as a recurrent. Okay, that means the output of the present node. Okay, the suppose this is the present node. The present node depends on the previous node. The previous node output depends on the previous node output. Like that, we are going to get the, it's calling the calling the same function multiple times. That's why it's called as a recurrent neural networks. Okay, now so this is the way we are going to generate the output. So this is simply called as a RNN. Okay, now this is the time out input for the our node, and we are going to generate the two outputs. One output is called as a present node output, and second output is called as a hidden information or hidden node information that is carry forward to the next node as input. So the next node, okay, depends on read the present node input. Okay, that is a xt plus 1, and also based on the previous output, that is ht, we are going to generate the OT plus 1, and also we are going to generate the HT plus 1. Okay, now so like that, finally we are getting the output based on the help of our two inputs. Okay, now present node input and the previous node output. So simply this is called as a recurrent neural networks. So here, see, this is the normally these are the input. Okay, and this is the our output. Okay, this is our output. In between, what happened in the normal neural networks, there are n number of hidden layers are there. This is hidden layer 1, and this is hidden layer 2. Okay, this is the hidden layer 2, and this is our hidden layer 3. Okay, like that, we are having the n number of hidden layers are there, and each hidden layer contains n number of neurons are there. Hidden layer, neuron 1, neuron 2, neuron 3, like that. Hidden layer 1 contains 4 neurons are there. Hidden layer 2 contains 4 neurons are there. Hidden layer 3 contains 4 neurons are there. Like that, it's a fully connected network. It's a fully connected network. We are giving the input and we are going to get the output, but we are getting the output. But it takes a lot of time in order to execute all the things. So in order to avoid that one, okay, if any loss is there, you have to update in a back propagation, perform some operation. Okay, and we have to update all the weights, and once again we have to go forward for propagation. You will get the output like that. Okay, same thing is repeated in the form of a one recurrent neural networks. Okay, now so in the recurrent neural networks here, there are different timestamps are there. Okay, that is at ht minus 1, xt minus 1, there is some input is there, that is u. Okay, for that okay, that content that reads the provide the input for the neuron. That neuron is generate the two outputs. So one output is output at a time t. Okay, at a time t minus 1, that is okay, and at that same time we are going to get the output as a ht minus 1. Ht minus 1 nothing but hidden information. That hidden information is carry forward to the next layer as a input. Okay, for this neuron, second neuron at a time t okay, at a time t input, we are having two inputs are there. One is at a time t at a time t we are having the xt as input, and in the previous node we are having the output is there now, that is a ht minus 1. So based on these two inputs, we are going to generate the output. Okay, that is OT. Okay, and also we are going to generate the hidden information as a HT, that is carry forward to next layer as input. So like that, in order to generate the final output, we are going to use the multiple okay inputs. Okay, this is a Federer, for example, giants all time great. Okay, now all-time great. So at that time, so after reading all the inputs and find out the new words. Okay, and based on that new reading all the inputs only, then only we are going to generate the final output. So this is belonging to sports or okay, political news or what it may be. Okay, now general news like that. Okay, now so this is because of the recurrent neural networks. Okay, now so this is that simple. This is a simple representation of the recurrent neural networks. and this is the expansion of the that recurrent neural networks. Okay, here there are different types of different timestamps are there. This is the at a t time t minus 1, at a time t, at a time t plus 1, and at a time t plus n. Here the n number of inputs are there. Okay, and then we are going to generate the output at a time t minus 1, at output at a time t, at output at a time t plus 1, output at a time t plus n. Okay, like that we are having the different outputs are going to generate. So in all the cases, that node is very, very important. What we call RNN node is the very, very important. So we have to see the what is the structure of the RNN. Okay, now, sir, Ashok sir, hello,
Sir, sir,
sir,
sir.
is it okay, sir? The flow,
Yes, sir, yes, sir, yes, sir.
is
You can
it
continue, sir. Continue.
is it understand?
Understand, sir. Understand.
Okay, if you have any doubts, please ask me now. Okay, now.
Okay, sir. Okay, sir.
Okay, thank you, sir. Now, like that, we are going to get the out things. Okay, now. So here, this is a simple representation of the RNN. Okay, now with the single one node only. The recursively calling the same node multiple times. Okay, now we are giving the input, and based on the present input, we are going to generate two outputs. One is output at the time t, and the same output is given to next layer as a input. Okay, now. So that is called hidden information. So once again read the present node input, and based on the previous node in previous output, we are going to generate the once again output. So like that we are going to perform the things. Okay, so simply it is called a recurrent neural networks. There are different types of recurrent neural networks are there. That is called as a one-to-one network, and one-to-many, many-to-one network, and many-to-many networks, and many-to-many networks. There are n number of different types of RNN nodes are there. Okay, RNN models are there. See here what happened now. We are giving there is only one node is there. Okay, only one node is there. For this node, we are giving the only one input. We are going to generate the one output. So simply this is a one-to-one network. And here in this model, in the second model, what happened? We are giving the only single word. We are giving the single word. We are going to get the multiple keywords, multiple outputs. Okay, now. So here we are having the different nodes are there. This is node 1, this is node 2, node 3. Okay, and for each node we are going to generate the output O1, O2, okay, O3. That means for a single input value we are going to generate the multiple outputs with the help of multiple what we call multiple recurrent neural networks nodes are there. Okay, now. So then here what happened now, here multiple inputs are there. That is multiple inputs of I1, sir, okay, now I1, I2, I3. There different inputs are there, and reading the all the inputs after completion of all the inputs, then finally we are going to generate the single output only one output we are going to generate. Okay, now. So with the help of multiple neurons, okay, RNNs, okay, we are going to generate the only one output. So simply this is called as a many to one output. After reading all the inputs, and finally we are going to generate the single output. Okay, now. So here what happened now? We are reading the there are multiple inputs are there, like I1. Okay, I1 input 1, input 2 at a time 2. Okay, input to 3. So for example here, 3 inputs are there. After completion of after reading the first input, and after reading the second input, after reading the third input, we are going to generate the three outputs. We are generating the three outputs. So after completion of all the three words, we are going to generate the three outputs. Okay, now. So simply this is called as a many to many, one type of model of the RNN. One more thing is that is here, after reading the input 1, input 2, input 3, simultaneously we are going to generate the output. Okay, simultaneously we are going to generate the output after reading the first input. So this is also one type of one-to-one, many to many recurrent neural networks. They are the different types of RNN models. Okay, now. Then, so you know what is the here this is the structure of the our RNN, simple RNN model. So you are giving the input, and we are getting the two outputs, that is HT and OT. And for this, the basic heart of the RNN heart is a RNN node only. RNN node only. So what it does, how it does, okay, that is very, very important. Okay, now. So here we are having the two things are there, that RNN node contains tan h operation. We are going to perform the tan h operation. That is very, very important. Okay, now. So we are reading the present node input, and we are reading the previous node output. With the help of these two inputs, and perform some operation, concatenation operation here, and perform the things. That output is this output is given to tan h and to generate the output. Okay, based on the tan h. Tan h is nothing but a e power x minus e power minus x by e power x plus e power minus x. That value between the -1 to +1 value. Okay, so whatever the value you are going to generate here, that is based on the if you provide this one. Okay, here we'll get the values between the -1 to +1. That value is going to be given as a output. That is a OT or HT. Okay, now here series one, we are going. We'll see the in detail here. We are reading the present input. Okay, that is at the time t. At the time t. Okay, at the time t, there is some word vector is there. Some word is there. That is converted into numerical characters. Suppose hello is there. That hello is going to be converted into single word. Okay, one vector. Okay, numerical character. Okay, now with the help of our word to vector like that. Then we are going to convert with the help of embedding. With the help of embedding, we are convert that into word to vec. After that, we are going to get the output as a, for example, this is a 1000 word, 1000 characters are there. Okay, for example. Okay, now that is converted into 200 length word. Okay, 200 length word. Okay, then here also in the previous node output also we are having the 200 length word is there. Okay, 200 length word is there. The 200 length word is okay. Now we are going to multiply to that HT minus 1 is multiplied to corresponding weight value. That weight for everything there is a weights are there. Okay, now. So now here after reading the input from the numerical values, English character converted into numerical values, that word is converted. Okay, that word is multiplied to weight values WHX, weight on the input value. After that, we are going to get the output also in the form of a 200 word. Okay, now. Okay, and this 200 word length is also multiplied to weight value. We are going to get the word as a 200 length word. Okay, now 200 length word. Okay, now we are going to perform the some plus operation on the that means HT minus 1, that is multiplied to WH. Okay, and plus that is going to be multiplied to HT. Okay, HT that is multiplied to WHX. Okay, now we are going to get the new word. That new word also having the same length only. Okay, both this is one length word is there, 200 length words there, and these 200 length words are there. Both are going to be concatenated. We are going to get the new output. Okay, that is also in the form of a 200 length word. Okay, that 200 length word is given to tan h. Okay, the tan h is going to given perform some operation that is convert the values between the -1 to +1. Okay, based on that we are going to convert. We are going to transfer to next layer as an output. So this is also having the 200 length word only. Okay, now. Then after that, what happened now? So the 200 length word is converted into, okay, that is multiplied to weight value. Okay, and we are going to get the output. So like that we are going to get the output. So the OT, okay, there is some formulas are there. So here this is the way we are going to get the things here. See this one. The OT nothing but how do we get the OT value? OT equal to so here the tan h value, whatever the tan h is there now, the tan h is multiplied to WHY. Okay, we'll get the output as a OT. So that OT is nothing but a output at a time t. So like that in all the cases you have to apply this forward propagation. Okay, now see this one. For example here xt minus 1, and that is embedded with to word. Okay, and we'll convert the some length of the word. Okay, 200 word, and here also we are having the 200 word character length is there, that is multiplied to WHH and WHXY. Okay, and we are getting the output as a 200 word length word. Okay, that is a 200 length word, and then that is given to tan h. It convert the values into -1 to +1 range, and we are going to get the output as a 200 length word only. Okay, that is carried forward to next layer as input, and also same thing we are getting the output as a 200 length output. Okay, so like that we are going to get the output in all the cases. Same thing is are going to be carry forward to the next layer. Okay, then once again at the time t we are reading the input present node input. Okay, and that present node input we are going to embed it, and that embedded word is can we multiply to whx, and then whatever the previous node output is there, that is multiplied to whx h, and then perform the sum operation. That output is given to tan h value. Okay, the tan h after that we are going to the same value is transferred to next layer as input, and whatever the output is there, that is multiplied to why. We are going to get the output as new word here. Okay, now so like that we are going to get the new words on the each and every neuron RNN node. Okay, now so here the tan h plays an important role in the RNN. Now, okay, so simply this WHX and WHY are represented in the form of a different values are there. So U nothing but a, U nothing but here what we call WHX, W nothing but a W weight on the hidden information, V nothing but a W weight on the W. Okay, your output value. Okay. Now like that we are having the three weights are there. Three weights are there. The weight on the previous node input, weight on the present node input, weight on the output node. There are three weights are there. So like that we are going to apply your RNN nodes. Okay. So series one here, this is the final node. Okay, final output is at the OT. Okay, so at the time t, where the present time t. Okay, there, for example here, the inputs are federal, giants, all, time, grades. Okay, these are the different inputs are there at a different timestamps. At the time t minus 4, the input is federal. At the time t minus 3, the input is giants. At the time t minus 2, input is all. At the time t minus 1, input is time. At the time t, okay, present time t, the input is grades. Based on all these input values, we are going to get the output as here. Okay, now at this node it becomes sports news. Okay, now it becomes sports news. Okay, now so now here what happened now, we are going to get the different weights are there now. U is one weight is there, W one weight is there, V is one weight is there. V nothing but a weight on the output node, and V U nothing but a weight on the present node input value. Okay, W nothing but your weight on the previous node, weight on the previous node output. Okay, so like that we are going to get the multiple weights are there. What is the meaning of loss here? The loss is nothing but we are going to compare the present node output with respect to actual value. Y nothing but loss is there. Loss equal to y comma OT. OT nothing but a present node output to y nothing but a actual output to. We are going to compare these two outputs. Okay, if any loss is there, if both are the same, then we can stop the process. If both are the different values at the time, what happened? You have to update your weight values. Update your weight values. You have to update. You have to go back into backward propagation. You have to update your all the weights. Okay, we have to update V value. We have to update W value. We have to update V value. We have to we have to go back to previous node output. Okay, you have to update U value. You have to update W value, and you have to go to previous node, and you have to update your U value, and you have to update your W value. Okay, and U value, and you have to update your W value, and here also you have to update your U value and W value. So that means if any loss is there, okay, so we have to update your V value. Three weights are there now. One weight is a V value, and second is a W value. Third is nothing but your U value. U nothing but a weight on the input value. W nothing but a weight on the previous hidden information. V nothing but a weight on the present node output. Okay, so in order to minimize the loss function, you have to update your all the three weight values. After updating your weight values, once again you have to go back to a forward direction and find out the output value. Okay, so until if you minimize the loss function. So simply this is called as your forward propagation and backward propagation. In like ANN, okay, like in the ANN also we are having the forward propagation is there as well as a backward propagation is there. Now, like that here also we are having the forward propagation and as well as a backward propagation. Suppose here, for example, we are having the only one output. We are considering the output only at time t, okay, now at the last time t, okay, at the time t only we are considering the output. So that's why at that case, okay, what happened now? We are going to get the only one output. That's why we are having the only one v value, one weight value is there. For example, if you are having the multiple outputs are there, if you are considering if your output is depends on multiple timestamps, okay, we are considering the OT at T4, okay, we are going OT minus 3, OT minus 2, and OT minus 1, okay, at that time. So you have to update all the five weight values, okay, on the output node, okay. So this is the way we have to update our weight values. If we are considering only one output now, at that time we don't consider that these weight values, these are weight values, we will not update these weight values. There is no importance for these weight values, okay. But if you are considering only all the output values, okay, at that time you have to update your weight on the all the nodes, okay now. So that means each node contains three, two inputs are there and two outputs are there, okay na. And here there are three weights are there. One is a previous node output, weight on previous node output, and weight on the present node input value, and v nothing but present node output value, okay. So like that you have to update your weight values. Simply this is called as a forward propagation and a backward propagation. And here, see this one, this is a simple node structure. So already we discussed this one, HT, that is embedded to some new word, okay, that it contains some length of the word is there, okay. It contains 200 word is there, vector is there, okay. And here also the previous node contains 200 word length word is there, and that is multiplied to WHX, and this is multiplied to WHH, okay. And we are getting the new words. The new words are having the same length only. Then we are going to perform the plus operation. On the plus operation output, we are going to provide the tanh operation. Then that output is given to as next level output, okay, as input, and that contains also 200 length word only, for example only, okay now. And the 200 length word is converted into multiplied to weight values. We are going to get the new weight value, new word, okay now. This is the new output value, okay. So here WHX, H and WH5 are represented in a W, U and V. So here WHX is nothing but a U and WH5 nothing but a V. WHH is called as W. So what we call ZYT and ZHT nothing but your intermediate results. Okay, here ZYT nothing but your present node input value. Okay, output value, and ZHT nothing but your ZHT is nothing but your present node performing the summation operation. We get the output as a ZH5. Sigma nothing but activation function. Here sigma nothing but tanh operation, and y nothing but your here y nothing but your output value, actual output value. L nothing but your loss function. Now, first of all, what I have to do, multiply the previous hidden state with the weight matrix. You have to multiply the HT1 minus 1 is multiplied to weight matrix W, and then multiply the input word with the weight matrix U, and then add the 1 and 2 and add the bias term. Okay, then apply the nonlinear function tan h value, and then a copy of the fourth value is transferred to, okay, multiply with the weight value. So after perform this one, we are going to ZH5 is given to input for the tan h value. We are going with the help of tan h, we are going to get the nonlinear function. That output is multiplied to V value, okay, matrix V value, and then we are going to apply the nonlinear function. Okay, then we are going to get the output that one. Then find out the last function. Okay, then at the same time, whatever the output is there, that is carry forward to next layer as a input. Okay, so this is the way you have to update your you have to perform different operations on the RNN. Okay, so here ZHT nothing but a ZHT. This is nothing but a ZHT nothing but a U into XT. U ante what we call present node input value weight value. Okay, U into XT, plus W into HT minus 1 plus bias term. Okay. Then after that we are going to get the output. Okay, now that HT equal to whatever the output is there, that is given to sigma of H of ZHT. So whatever the output is there now, ZHT is given to sigma H. Sigma H is nothing but a tan H only. Okay, now then ZYT, we are going to get the ZYT here. So ZYT is nothing but a whatever the HT is there, HT is multiplied to V value, and bias term we are going to add. Okay, bias term we are going to add, that is given as a ZYT. So then OT, once again we are going to get the OT. OT nothing but a sigma Y of okay ZYT. Okay, with the help of nonlinear function. Okay, therefore we are going to get the output value. Okay, now here the 4 steps you have to carry it out in the recurrent neural networks. Okay, we are find out the loss function. If any loss is there, the loss equal to the difference between the OT, that means present node output, and actual output. Okay, we are comparing the differences. If any loss is there, we are going to get the output, and that you have to minimize the next iterations with the help of back propagation. Okay. So now if any loss is there, you have to apply your backward propagation, and you have to update your all the weight values. You have to update the V value, you have to update the U value, you have to update the W value, U value, W value, U value, W value. Okay, in all the previous error nodes, you have to update all the things. Okay, simply this is called as your backward propagation. Okay, now so with the help of backward propagation, you have to update your new weight values. So in order to update new weight values, there is a formula is there. This is a V equal to V new equal to V old value minus alpha into derivative of loss with respect of derivative of V. Okay, now, and also you have to update your W old new value equal to W new value equal to W old value minus alpha into derivative of loss with respect to derivative of W. Okay, with respect to W. Okay, previous one is with respect to U, V, and then you have to update your U value. Okay, derivative of new new value equal to V old value minus alpha into derivative of loss with respect to derivative of U. Okay, so like that we are going to update your weight values with updated new weight values. Once again you have to apply forward propagation, then we get the better results. So you have to continue this process until you are minimizing the loss function. Okay, so here in the loss function there are different types of things are there. One is root mean square error is there, and for the regression problem we are using the root mean square error, and SSE. Okay, and then for the binary class classification we are using the binary cross entropy loss function, and for multi-class classification we are using the multi-class cross entropy loss. Okay, if it is a regression problem, then we have to apply mean square error, sum of the squared error. Okay, like that we will apply the different techniques. Okay, if it is a two-class classification problem, then at that time we are going to apply binary cross entropy. If it is a multi-class classification problem, then go for the multi-class cross entropy loss function as a optimizer. Okay, now so like that we have to perform the things. So now in order to understand this one, first of all, there are different steps are there. Okay, already we discussed the procedure to solve the problem in the help of our deep learning technique, or okay, how to solve the problem in deep learning. Okay, the first step is understand the business problem. Okay, then based on your requirements, based on your problem statement, you have to import all the library files and read the data set. For here we have to require the data set in the form of a text messages. Okay, then we have to perform the data pre-processing step, then data splitting for the training purpose and the testing purpose, and then we have to build the model. Okay, here the model is nothing but your RNN model. The model is nothing but a RNN. Okay, now, and then you have to compile the model. Okay, for the compilation, if any loss is there, we have to apply your loss function also. Okay, already we discussed the cross entropy loss, binary cross entropy loss, or multi-class cross entropy loss, like that. Okay, you have to use the compilation process. and we have to apply optimizer also in the model compilation. Then model training, that means you have to fit with X train data and Y train data. You have trained the model for whatever the model are building. Okay, with the help of training data, we have to train the model, and then model evaluation with the help of test data. Then finally, we are going to get the performance of the our model.